Okay, so good morning and sorry for delay and interruption. So today we want to continue our lesson of exponential functions, but I just want to concentrate a little bit of exponential functions so that you can solve them without invoking the notion of logarithm that we will study later, okay? So first of all, I want to define for you what is the meaning of an exponential equation, and then solve two examples, and then we are done for today. I will give you a little bit of time to refresh your memory, and then you remember that whenever this chapter is finished, we will have a test containing two chapters simultaneously. And I don't think that's too much, because the previous chapter was just mainly solving systems of equations, and I think you are very good at it. And the first part was also lines, slopes, I don't know, intersection of lines and things like that. And I don't think that's a hard problem. That's a hard thing for you as well. So yeah, I think the technical problem for you will start from the next lesson, which we will deal with logarithms, which is actually a very important topic in mathematics. But it doesn't mean that it is hard, but you need to get used to a way of thinking a little bit about that. But it is something that you need to concentrate, because it will be for you forever if you want to follow mathematics or engineering programs in your university studies. Okay, so today I want to talk about exponential equations. So equation, again, you know what's the meaning of an equation. It's an equality including one or more unknowns. In this case, we just concentrate for the first example in one unknown, and there is another example, as you see on the next page, hopefully here, that's including two unknowns. Okay, so here, so it means that what is the notion when we say an equation is an exponential equation? And the definition here, an equation in which the unknown of the equation appears in the exponent for natural reasons, is called an exponential equation. So here there is nothing to solve. I'm just giving you some examples of what I mean, and why actually what mathematicians mean when they say exponential equation. This is an exponential equation, and of course extremely simple to solve. Why this is an exponential equation? Because first of all, you see equality and you see an unknown in your equation, but it appears in the exponent. It's not like 2 times x equal to 4. This is not an exponential equation, because the unknown does not appear in the exponent. But here you see it is 2 to the power of x equals to 4. And of course, in this case, if I ask you what that x is, you immediately can answer that. Yes, x is equal to 2. Okay, and then just let me motivate you for the next lesson. But if I ask you 2 to the x equals to 3, then it is a little bit problematic, yes? Is there any number so that 2 to that power becomes exactly equal to 3? We will see this. This is a number that mathematicians actually artifact, and they call it the log of 3 in base 2. Okay? So this is an exponential equation. Another example of an exponential equation is this one. Again, I have equality, but you see your unknown appears somewhere in the exponent. Here I have a little bit more complicated exponential equation, but still it's an exponential equation because I have equality, and you see that this x appears in the exponent. This is also an exponential equation. You have equality, and then you see that this x appears in the exponent. Okay? But now the problem is that how can we solve exponential equations? Okay? So the point in this lesson, I am just concentrating on those exponential equations that if you want to solve them, you have to use this idea. If I tell you 2 to power x is equal to 2 to power y, what you can conclude about x and y? clearly they have to be equal. Yes, 2 to power x is equal to 2 to power y. This would then imply that x is equal to y. So if I tell you 3 to power x is equal to 3 to power y, then you can conclude the same thing, x equals to y. So in principle, if I have equality between the powers of the same number, then it means that I can conclude that the exponents have to be equal as well. So that is the core idea in this lesson. So, but sometimes we don't know what to do. 2 to power x is equal to 3, but apparently we don't know that power, so that 2 to that power becomes equal to 3. That is the motivation behind why we need logarithms in the first place. But don't be concerned about this for the time being. Here I am just giving you a little bit simpler version. Okay, so if I ask you solve this exponential equation, so let us do it. What I do, I have to do this. I would write 3 to power 2x. Can I write 9 in some way as a power of 3? It's extremely simple. 9 is nothing except 3 to power 2. So in this case, I don't need the notion of what will come later as logarithm. It's extremely simple. And now I can conclude from here, because I am going horizontally for an equation, I have to put arrows. And then what can I conclude from here? I am telling you that 3 to some power, I don't know the power yet, but 3 to that is equal to 3 to power 2. So extremely simple. It means that the exponent 2x of the left hand side should match with the exponent on the right hand side. And then this simply implies that x is equal to 1. End of the solution. Okay? Now let us do number 2. So what is your idea about number 2? How should I solve number 2?
Yeah, same thing.
The same thing means more elaboration, please.
Yeah, sure. You have 2 to the power of 2 minus 3x. Then you replace the minus 8 to the the right hand side. So you have like 2 to the power of 2.
Exactly.
3x equals to 8.
Yeah, thank you. Yeah, thank
2
you.
to the power of 3.
Yes. So as you said, first of all, I move 8 to the right, so it becomes positive 8. But every one of you hopefully immediately realize that there is a connection between 8 and a power of 2, yes? So it becomes 2 to power 3. And then the same story, yes? I have a power of 2 on the left, I have another power of 2 on the right, and these powers are supposed to be equal. So it means that the exponent of the left-hand side has to be equal to the exponent of the right-hand side. So then it means that I can conclude that 2 minus 3x is equal to 3. And then, 2 minus 3x equals to 3. And then I have to solve this one. So you see that you reduced your problem from an exponential equation to an equation which is familiar for you even from Math 1C, yes, or even before that. So you immediately know how to solve that. So what we do, we reduce the new problem, which is an exponential equation, to a problem that we already know how to solve, and then we are relieved, so because we can solve the problem now. So what happens, I have minus 3x, I move 2 to the right, it becomes 3 minus 2, which is 1. So let me just write it quickly. And then I am just looking for x, so my duty is to make x alone, so I divide by minus 3, and this becomes a third, minus a third, yes? So this is the answer to this question. And of course, I have given you a little bit non-trivial examples. And now I want to also test this pausing option ability. So I will pause the video. I will give you a little bit of time. This might be a little bit challenging. I wouldn't call number 3 challenging, but number 4 might be a little bit of challenge. So I want to give you I don't know, 10 minutes to try to work these two yourself first, and then if you cannot, I will come back to you and give you one by one, okay? I don't think you will face a problem with 3 if you think wisely, but you need to remember a little bit more things from your previous studies for number 4, okay? So let me just pause the video at this point. Yeah, please try to work on it, okay? Okay. So number 3, I don't think it should be hard to guess what to do. Anyone except Ruko and Hussein? Do you have any ideas what to do? Another person? Anyone else?
Maybe you factor out the x?
What? No, factoring out an x. X is in the exponent, so don't get confused with this. I don't know. In this case, might be you can say that I can factor x out, but x is not a factor that I can factor it out. It's an exponent.
Okay.
Okay. So, for example, Hussein, can you tell me what did you do?
Yeah, I put I saw that 3 to the power of x was a common factor.
Something happened. I cannot hear you. Hello? So I lost probably the connection. Rocco, can you tell me what to do now? Can you hear me? Or that's from my side? Yeah.
Yeah, I hear you. So, yeah, you just factor out 3 to the power of x. So then it will
Sorry.
be...
My
okay.
computer literally died at the worst moment possible. I'm so sorry.
Okay, no problem. So let us give this chance again to Hussein. Okay, so can you tell me what to do?
I put 3 plus 1 in parentheses, right? Times 3 to the power of x is equal to 36.
Okay, so but I would prefer to do it in 2 steps. Okay, so let me write vertically this time. It doesn't matter. Let us interchange between these two. Okay, so I would write it in 2 steps. Instead of 3 to power x plus 1, I would write 3 times 3 to power x is equal to 36. Of course, factorization is also correct, but why we should factorize? I would say that here I have one thing, that's something, it's in the box, but I have 3 of those boxes again. Of course, when you say factor, that's also correct. When you factor 3 over to the power of x out, what is left here is 1. What is left from this is just 3, and then you write 1 plus 3 is 4. But we don't need to spend time on it. We say that, okay, I have something, which I call it the box, and I have 3 of those boxes again here. So 1 box here, 3 boxes here, so it is clear that at the end I will have 4 boxes. So I would prefer to write it in this way, and then it becomes 36. Yes?
When you put the extra 3 there, it's from the plus 1, right?
Yeah, okay, so let me remind you of this formula if you have forgotten. If I have some number to the power of the sum of 2 exponents, this can be written as a to the first one multiplied by a to the second one. So yes, you are right. So 3 to power x plus 1 can be written as 3 to power x multiplied by 3 to power 1. But everyone knows that 3 to power 1 is just 3, and I prefer to write 3 on the left, if of course it doesn't matter. And then this becomes this. So yes, you are right. The reason that I was able to write this in this way is because of this formula from the power rules, yes? And then I would say that, okay, there is, this I don't know, but I know something. I know what is inside this black box. I don't know. 4 times of that is 36, so it is clear 3 to power x, 3 to power x is equal to 36 divided by 4, and this means that 3 to power x is equal to 9. But again, 9 can be written as 3 to power 2, Now I have equality between two powers with the same basis, so it means that I can conclude that the exponents have to match. And that is the simple solution for this problem. Okay, so now let me open up a space here to solve this one. So let me just move this a little bit higher. Yes, so this is the rule that we had for this problem. Let me, by the way, make it a little bit smaller. We don't need this to be that big. I can put it next to this one. Let me make it even smaller. I don't think you need it that much. Yes, I can put it somewhere here. Okay, now let me draw a border here to solve number 4 here. So number 4. Okay, now let us give this chance this time to Rocco. Okay, so what was your idea for solving this problem, number 4?
Yes, so the first thing I did was I wrote 4 to the power of x as 2 to the power of 2 to the power of x. Yeah, exactly. So let us follow you step by step, and if it needs correction, then I will correct it. So that's a very good starting point. So what Rocco is saying is, okay, I would write 4 to the so instead of this 4, I would write 2 to the 2, and then again to the power of x, and then I have so if I understood you correctly, you want to repeat the rest. Okay, and then what's the next step? So then we can use an auxiliary variable. We can use 2 to the power of x is equal to t.
Exactly, but before that I prefer to do a little bit of change to make it transparent, you know. Because in this form, yes, you are completely right. You see 2 to the x here, but still I don't see 2 to the x here. But
you can interchange.
Exactly. So let us do that. Okay. So 2 to the 2 to the x. I hope that everyone don't have any problem. No one has any problem here. So 2. It becomes 2 to the x to the 2. There is no difference between these two. Why? Because if I ask you what is this, you would say this is nothing except 2 to the product of 2 and x. If I ask you what is this one, you would say the same thing, 2 to the product of x and 2, which is 2x. So both of these expressions, you see, are equal to the same expression 2 to the 2x. Okay, so if I take this one and replace this one instead, I am not doing something wrong. But is it useful? Yes, because if you heard what Rocco said, you will see that this is useful. So the first step, I interchange these two, and now the idea of auxiliary variable becomes transparent. Yes, so as Rocco said, so I would say here, let 2 to the x, as you said, let me call it t. Okay, then what happens? Instead of this one and this one, I just simply put t and t. But then what happens? It becomes t squared, and then this is a very clear equation for you. Hopefully this becomes t squared minus 20 times t plus 64 equals to 0. And now everyone knows that this is not a hard question at all. This is just an ordinary quadratic equation. So what we have done, by using these tricks and techniques, we reduced our problem from an exponential equation to a simple quadratic equation. Here we are relieved actually here, because we know what to do with this equation. Okay, but so momentarily you just focus on solving this problem, and then when you found t, because your original variable that you were looking for is x, not t, you found t, you put t here, and you find x, as we usually do when we have auxiliary variable involved in the problem. Yes, so what I have to do here, I would
I don't know, let us write delta. So delta is b squared minus 4ac. If you prefer delta formula, of course here you can also use pq formula. Might be in this case pq formula is a little bit easier because this number is even, okay? But anyway, let us stick to this delta formula. So this becomes 20 to the power of 2 minus 4 times 1 times 64. So this is what? It's 400. Minus 4 times that number is 256. Yes. So what is left for me here? 54. Am I right? 20.
I think so.
Yes. So this is a little bit a strange number for me. So what is the number? 400. So this is 44, 144. Yes, now I was making a mistake. Okay, 144 is positive, but I need to write a formula, if hopefully you haven't forgotten. So it is minus b plus or minus square root of delta divided by 2 times a, which is 2a. Okay, but here minus b is minus 20, so minus minus 20 becomes 20, and then I have plus and minus square root of 144 divided by 2 times a in this problem is 1, and the square root of 144 is 12 if you use your calculator or if you are familiar with that number, and then divided by 2, so you see that I get 2 answers for t. Okay, so then what happens for t? There are 2 answers. So t is either equal to 20 plus 12 divided by 2 is 16, or t is equal 20 minus 12 is 8 divided by 2 is 4. So these are the values for t, not yet x, okay? But I want to find x values, then it becomes clear. I would say that, okay, if t is equal to 16, 2 to the x becomes 16. Why? Because this was the name, this is the meaning of t. T is nothing except 2 to power x. When t is equal to 16, instead of this t I put 16, and then immediately it becomes clear. What is that x? The x is 4, yes? Because x to the power of 2 to the power of 4 is 16. And it becomes, so let me write, or it might happen that t is not 16, t is 4, but then it becomes clear. 2 to the x is equal to 4, and then what I get is that x is equal to 2. So the answer to the problem are actually these two. So what you need to write as the answer are not the t values, are the x values. So x is equal to 2, and then x is equal to 4. Yes? And then we can put this in another box here. Okay, so this is a problem here that you see that the notion, the idea of auxiliary variable still works. By the way, let us check, is GeoGebra capable of solving this equation? Let us check that. So let me go here. So do you remember, if you want to solve, what I have to do, I need to change my view from, I have to go to CAS view, okay? So I go there, so I will write SOL. Okay, here I don't want to solve a system. You see, you go solve, but there is a standard here. You see, if you use this one, that's also okay, but you need to type your equation, and you need to emphasize that my variable is x. But because usually variables are x in solving equations, there is also a separate command here. So I would prefer to use this one, then I don't need to type the rest of it, okay? So I would say solve this one. And then, by the way, in GeoGebra 6, you can just push delete first to get rid of that, and then you can start typing. So 4 to the x, and then I go down. I have minus 20 times, so let me use times here, 2 to the x, and then I go down once more, plus 64 equals to 0. Okay, so if GeoGebra is capable, by the way, the pronunciation is GeoGebra because geometry and algebra. Geo is not, we don't say geometry, we say geometry, so this pronunciation should be GeoGebra, okay? Okay, so yes, it is capable of giving you the answers. So x equals to 2 and x equals to 4 are the answers in this case. Okay. Okay, let us go back, and I want to give you a little bit of time to solve the other problem yourself. Here, I just want to tell you that whatever you had before, you can combine the problems if you are creative yourself. Yes, here I have a system of equations, but this is not a normal or a standard system of equations. This you can call it, if you like to, you can call it a system of exponential equations. Okay. Here, how many unknowns are involved? Two unknowns. One of them is x, one of them is y. So I just want to clarify, the whole expression you see here is in the exponent. As if you see, I am just typing this with LaTeX system, yes, LaTeX, which is probably the final possible way of just typing mathematics and every typing. So you see that automatically it's taking care of putting exponents with the smaller fonts, you know, they are smaller. So don't get confused, okay, that the whole expression here is the exponent of 25 here. Of course, I haven't taught you how to solve this problem, but there is nothing to teach you. If you can put the pieces of your math knowledge next to each other, you can solve this puzzle yourself. Okay, so let me give you 5, or I don't know, if you need more, I will give you more. Let us just go for 5 minutes. I want you to think about this problem. In this problem, you're supposed to find the value for x and y. Okay? Okay, so if you don't mind, let me solve this problem. So I think, yes, Kajal's answer was correct. So x is supposed to be equal to 3 and y is equal to 1. But let us see why. I hope that most of you were able at least to understand what to do. Yes, here I am dealing with two equations. Both of them are exponential equations. Why the first one is an exponential equation? Because you see that my unknowns x and y appear in the exponent. The same for the second equation. Okay, but let us try to simplify this. So hopefully, by the experience from the previous problems, you'll learn that if I want to solve an exponential equation, I should be able somehow to reduce the exponential equation to a normal equation. By a normal equation, I mean an equation which is not exponential, and hopefully we can solve that problem. Okay, so this is the way that we have to do it here. But let me concentrate on the first bit. Okay, so 8 to power 2x plus 1 is equal to 32 times 2 to the power of 4y plus 12. I don't know how much you have these numbers in your memories. I think every one of you should know what is 8, how 8 relates itself to 2 as a power, and I think it isn't hard to realize that what 32 is. But if that is hard for you, if you don't have it in your memory somehow, you can use the trick that we learned in Math 1C, yes? So you can factorize it. For example, you say that I divide this by 2, it becomes 16. Do you remember on the right hand side you are only allowed to write prime numbers? Okay, so I chose 2, which is a prime number, and I divide 32 by 2, it becomes 16, and then I divide this 16 by 2, it becomes 8, divide 2, it becomes, and then you know that if you continue this process, it doesn't matter which number you have started with, it always ends with 1, okay, and then that is the final form of the process. So this becomes 4, and then you divide by 2, it becomes 2, divide by 2, as you see, it becomes 1, and then you immediately realize how many 2's I see here, 5. So 32 is nothing 2 times 2 by itself 5 times, so it becomes 2 to the power 5. So what I'm saying is that if you don't have it in your memory, still you can do it. Let me choose the vertical version to avoid to putting these arrows all the time. So this, I would write 2 to the power 3 and then to the power 2x plus 1. On the right hand side, instead of 32, I write 2 to the power 5 multiplied by 2 to the power 4y plus 12. So let us do it step by step. Here I have an exponent, raised it to another exponent. So if you remember, there is a rule. A to the power m to power n, it becomes a to power m times n, yes? So if I go to the next step, it becomes 2 to the power. If I multiply, let me just do it step by step. You don't need to write all these details in the exam if you don't want to. Okay, here, which rule I am using? I am using this rule that if I have a to the power of n multiplied by, a to the power of m multiplied by a to the power of n, it becomes a to the power of n plus m plus n. Okay, so then the right hand side becomes 2 to the power of 5 plus 4y. So I don't need to make it more complicated, okay? And then the right hand side, I multiply these 3 inside, so it becomes 2 to the power 6x plus 3, and on the right hand side it becomes 2 to the power of, here I have 12 and 5. So this operation is being done on the top, so don't worry about that. This is something you need to replace it by its equivalent, and you know that 4y plus 12 plus 5 has a better name, and that name is 4y plus 17. Now you see that I have equality between two powers of 2. This cannot happen unless the exponents of both sides match. So this means that 6x plus 3 is equal to 4y plus 17. Of course, you shouldn't expect to solve this problem because there are two unknowns, and this, for the time being, this is just one single piece of information. Okay, but you know what to do. So for example, I would prefer to move 4y to the left and 3 to the right, so it becomes negative 3 and it becomes 14, and then of course you see that I can simplify everything by 2, so let us do that, why not? So this becomes this, 2y is equal to 7. So this is one equation. Now, but the point is that I am relieved because this is just a normal equation, yes? It's no longer an exponential equation. Okay, I can do the same thing, more or less, for this one, but immediately you realize there is a connection between 25 and 5 from power point of view, and this 25 is 5 to the 2. So I will start with the other one. So I would rewrite the first equation. I cannot do anything apparently with the first one, but in the right hand side I can write 5 to the 2 to the 2y plus 1 divided by 2, yes? But again, I can use the same formula here. I can write 5 to the x minus y plus 1 is equal to, and then this exponent 2 should be multiplied by that exponent. But don't multiply 2. I told you several times, every probably this problem, when it happens, I repeat it. It's better to simplify. Please learn that, yes? So we simplify this 2 by that 2, it becomes 2y plus 2. Sorry, 2y plus 1. So this becomes 5 to the power of 2y plus 1. Again, the same story. I have equality between two powers of 5, so it cannot happen unless the exponents match. Okay, so apparently you know that you are supposed to solve a system of equations, so this is the lesson from the previous chapter. So I would prefer, because this 1 and 1 will go away, I would prefer to use this substitution method, yes? So here I will keep x and I move 1 to the right, it will cancel that 1. I move minus y to the right, it becomes 3y, yes? It's better to use substitution method here. So here I will take this with me and put it here. So whenever I see x, wherever I see x, I replace it with this 3y. So this becomes 3 times 3y minus 2y is equal to 7. So let me for future tell you that I'm putting it here. And then it becomes 9y minus 2y is equal to 7. 7y is equal to 7. And then y becomes equal to 1. And then when y becomes equal to 1, I can put it back here and I find my x. So x is equal to 3 times 1. So this means that x is equal to 3. So the answer to this problem, as Kajal said actually correctly, is these numbers. These one solution again, let me repeat again, this is not two solutions. X equal to 3 y is equal to 1. This is the answer to this problem. So you see that we actually didn't do anything new. I'm just combining your math knowledge, one piece of your math knowledge in one problem. So this relates itself to knowing a little bit about power rules, a little bit about factorization, and then system of equations, as simple as that. Okay. Do you have any questions regarding the solution to this problem? Okay, so now I stop this recording and then you are free to work on yourself. You can, I don't know how much have you done from blue pages on the previous page, or how much you have done from exponential functions from this chapter. But you can work on any one of them, and then please let me know if you have questions. So let me first start.